Let's check out how back solving and familiarity with the relationships that test writers love make this GMAT geometry question a little bit easier. Here's what we know. The hypotenuse of a right triangle is 16 feet longer than the length of the shorter leg, and the area of this triangle is exactly 120 feet squared. Now the thing that really matters, our goal, is to determine the length of the hypotenuse in feet. Now, if we were going to approach this question algebraically, we would find a really tricky and work-intensive road ahead. But this question asks for something specific, the length of the hypotenuse, and we have actual numerical values in the answer choices, and that means that we can back solve here. When we back solve, we want to start with answer choice C, the middle value. Let's give ourselves a visual for what that would look like. So we have a right triangle, and we're saying that the hypotenuse of this right triangle is 40. That means that the other leg, which is 16 feet shorter, will be 24. Now we could throw 24 and 40 into the Pythagorean theorem, a squared plus b squared equals c squared, but remember, look for familiar relationships. So let's check out how 40 and 24 might help us avoid extra math. 40 is the result of 5 times 8, and 24 is the result of 3 times 8. So here is a Pythagorean triplet hidden from us, but if we know to look for it, we can maybe find it. This other value is going to be the 4 in the 3, 4, 5, and it's going to be 4 times 8, so that tells us that the other leg of this triangle is 32. Okay, now remember the area of this triangle has to be exactly 120 feet. So we're going to throw that into the formula. That's base times height divided by 2. That's going to give us our area, and our values we're testing, 24 times 32 over 2. Does that equal 120? Well, I don't want to do 24 times 32. I want to make this easier. That's about the same thing as saying 20 times 30 over 2, and that is going to be 300, which is way too big. So I'm looking for 120, 300, a lot larger than that. The beautiful thing is I can get rid of 40, but I can also get rid of 64 and 80 because those are just going to be even larger values. Plug in one answer choice, eliminate 3 answers that don't work. That is pretty great. And now we're going to move up and test another potential hypotenuse. Answer B, 32. All right, so now we're saying, okay, hypotenuse is 32. Take 16 away from that, we get 16. And again, we could use the Pythagorean theorem here to find out the length of the third leg, but we also want to look for those recycled relationships, the one the test writers love. What we want to notice here is that we're given, with 16 and 32, a 1-2 relationship. And that means we should recognize that other triangle that the test writers love, a 30, 60, 90, meaning that this would be root 3. So now we know that the base is 16 root 3. We can stop right here. The answer cannot be B because this area, 120 feet, does not have a root 3 or a radical 3 in it. So we know it's not going to be 32. If you're not convinced, think about it this way. You'd have to multiply 16 by 16 root 3 and divide that by 2. 16 squared is already 256. There's no way you're going to divide that by 2 and get 120. So we can be fairly certain that the correct answer is A, 26. And we were able to do that with very few math steps compared to the algebra that this question would normally take. Now, if you were convinced you could work through this problem using 26 as your hypotenuse, I guarantee you're going to find that the answer is in fact A. I wouldn't recommend taking the time to verify the last remaining answer choice when you're taking the test unless you're confident you have the time to do so. Trust in tried and true strategies and techniques like back solving to successfully lead you to the correct answer.